3.3 example 1, we start doing that completing the square. And before we do anything, I want to reiterate and focus on the idea that what we're looking to do here is get one of two forms, which is x squared minus 2ax plus a squared if it's x minus a squared, or if we have x plus b squared, it should be x squared plus 2bx plus b squared. And what we're looking to do is we're looking to manipulate these expressions to be what we call a perfect square trinomial. So the first one right off the bat, and I'm going to do something that some students like, some students don't. I'm going to rewrite f of x as x squared plus 2 times 3 times x plus 5. And the reason I want to do that is because it's a little bit easier to see now how this matches with x squared plus 2bx plus b squared. And it is the concept that based on these two comparisons, we need to make sure that b is 3, which means that b squared has to be 9. Now, some students will identify that, well, we already have 5, so I really only have to add 4 more, and that's fine. You have to subtract 4 as well, of course. I don't think that's the best technique to start this with. Instead, what I'm going to do is I'm going to take my original equation, and I'm going to use the f of x throughout here. I'm going to say that f of x is x squared. I'm going to leave it as 2 times 3 times x, but then what I'm going to put in is I'm going to introduce that positive 9. So I'm going to add 9, which means I have to subtract 9, and then the original positive 5 is still there. Now, again, because I've added and subtracted that 9, I have not changed the value. I have merely changed the appearance, and then we can kind of work forward from there. So the next step is this blue bracket is a perfect square trinomial, which means my function is going to be, instead of x squared plus 2 times 3 times x plus 9, I'm going to write that as x plus 3 squared, and then I'm going to clean up my constants. Well, negative 9 plus 5 is negative 4. And now we have our function in vertex form. Completing the square is one of those things that you have to do a ton of them. It will not click. It might, but it usually doesn't click until you have done, a dozen of these types of questions. All right, so in B, we're presented with a bit of a challenge here because the function has a coefficient on the x squared. If you look at our perfect square trinomials in the top right there, neither of them have a coefficient on the x squared. So the first thing I'm going to do is I'm going to get rid of that coefficient. And when I say get rid of it, I don't mean just cross it out and hope for the best. I mean, I'm going to factor that 3 out. Now, you could factor the 3 out of all 3 terms, but it's really important that whatever constant is there right now, we don't care about. It's just kind of one of those extra things we have to deal with. So for this question, what I'm going to do is I'm going to factor that coefficient 3 out of any term that contains an x. And then we'll leave that negative 9 alone for now. Now, really important that you have to make sure that as you're doing these processes, if you went backwards, you would end up right where you started. Because if you can't do that, you have changed the value and therefore, changed the function. So what I'm going to do is inside that bracket, I'm going to do the same thing I did above, and I'm going to write this as f of x is equal to 3 times x squared minus 2 times 2x. I'm going to leave myself a little bit of space and then put that negative 9 there. Now, what I'm looking to do inside this is set up that x squared minus 2 times sum a times x plus a squared is a perfect square trinomial. And I hope that looking at those two kind of above each other, we can identify that that a is 2, which means that a squared is 4. So inside the bracket, I am going to add 4 and subtract 4, because that makes sure that the value is maintained. So I'm going to rewrite that just so we can talk about exactly, because this next step is a little bit weird. I'm going to rewrite that as f of x is equal to 3 times x squared. I'll put the 4x back in there, but now I have plus 4 minus 4 in the bracket, and then minus 9 outside. Sorry, just a little bit less room there. Now, perfect square trinomials are trinomials. They have 3 terms, so that negative 4 can't be there. Now, in order to get numbers inside that bracket, that factored expression, I had to divide by 3. So in order to get this negative 4 out of the bracket, I have to multiply by what I factored out, which is to say positive 3. So my next line is going to be 3 times x squared minus 4x plus 4 minus 12, which is the 3 times negative 4, minus 9. And the advantage is x squared minus 4x plus 4, we set up to be a perfect square trinomial. So I can factor that. It's going to be 3 times x minus 2 squared, and then negative 12 minus 9 is negative 21. And now we have our function in vertex form. Anytime you have a coefficient on the x squared, it does make this technique harder, but it's very, very consistent that we want to get to the point where we have x squared plus something x, and then we're manipulating that with a constant to make it or to force it into a perfect square trinomial form. All right, just ran out of room there. I'm just going to move C to another page here. And we're going to do the same thing. It's actually kind of nice not to have a constant value because then you don't have to do any addition or subtraction after the fact. But again, in my perfect square trinomials, we don't have a coefficient on the x squared. So the first thing I'm going to do is I'm going to factor that coefficient, -5 in this case, out of any term that contains an x. So -5x squared divided by -5 is positive x squared. -70x divided by -5 is going to be positive 14x. All right, now I'm going to write that again. It is positive, so I'll show that x plus, I really want to stress that it doesn't have to be a or b. So if I put x plus n squared, that would be x squared plus 2nx plus n squared. Now, we want to set up x squared plus 14x so that it is a perfect square trinomial, which means that 2 times some n is 14, which means that n is 7. So n squared is 49. Now, you do not have to write this that I'm boxing here in red each and every time, but it is important that that is the thought process that goes into completing the square. And what I'm going to do now then is I'm going to say that f of x is the -5 times x squared plus 14x. I'm going to add 49 and I'm going to subtract 49 to ensure that I'm not changing the value, I'm only changing the appearance. Well, similar to example B, that -49 inside the bracket is kind of ruining our perfect square trinomial. Well, to get numbers into the bracket, I divided by -5. So to get this number out of the bracket, I need to multiply by -5. What that leaves me with is that f of x will be -5 times x squared plus 14x plus 49 minus, I guess that's going to be plus, right? -49 times -5 is positive 245. That's a crazy vertex. Last step is to factor your perfect square trinomial. Now, try to keep in mind that we set this up on purpose, that if I add 49, this will factor into x plus 7 squared. I always encourage students that whatever you identify or whatever you square is what goes into your factored form. So my final answer for this question, or completing the square, putting into vertex form, they're all the same for this question, is -5 times x plus 7 squared plus 245. And I'd like to reiterate that the advantage of this is if I gave you this green function and I said, where's the vertex? And you can't use a calculator, you're kind of hooped, right? Unless you have calculus in your back pocket, you cannot find the vertex from standard form without a calculator. So vertex form allows us to quickly, through inspection, I can tell you that the vertex for f of x is -7, 245. And the vertex is typically, maybe this is an overgeneralization, but it's usually the most important point on a parabola because it always corresponds with the minimum or the maximum value.